morning, this is Ms. Billerbeck, and we're going to talk about 3.5 scatter plots and lines of best fit. So scatter plots are a useful visual means of seeing relationships between two variables of bivariate, that means two different types of numerical data. So scatter plots are used for discrete, not continuous data, so that the data pairs are not connected with line segments. So what that means is we wouldn't be putting little line segments between all these, okay? So that just wouldn't make sense, all right? So instead, what we're going to do is try to find a line of best fit. Okay, so for a line of best fit, we would have something that looks like this. So this is a line of best fit or a trend line. Okay, so when we see that a trend line or line of best fit has a positive slope with x, as x increases, y increases, it has a positive association or correlation. So an association just means that the two variables are associated in some way. They have a relationship. A correlation means they actually have a correlation between each other. Okay, so they're very similar in meaning. We usually in statistics use correlation. So when we have a line of best fit that as x increases, y decreases, we have a negative correlation. So it means it still has a very strong relationship, especially as it's close to the line, but it just means as something increases, like as time increases, the money that you owe if you're paying payments decreases. That would be a good thing. Okay, so even though it's a negative correlation, it just means that as x increases, y decreases. Then we have the cloud of data. So when we have a cloud of data, that just means there's no correlation at all. All right, so I just erased the letter, so let me put that back on. There we go. All right, let's go to the next one. All right. So for this one, we are going to look at a few sample scatter plots, and we're going to describe the association. So let me go ahead and share the screen. There. That was it. Okay, view my screen. All right, so if I have the screen here and I'm looking at the association here, I see that I am going to have an association on this. So I can kind of estimate, I got a line that looks kind of like that. So that would be a positive association. Or a positive correlation. Okay, if I have this kind of data, I can see, oh, I have a negative correlation. So as x increases, it increases. So this is negative. Okay, and then if we have a correlation like this, well, it's just a cloud. It's everywhere. So there's no correlation here. Okay, so let's take a look at another one. So we can also estimate the line of best fit. So we want to do that. First, we want to find 2 points when we do that. So if we find 2 points, then from those 2 points, we can go ahead and find the slope and the point slope. All right, so let's take a look at this. So first, let me make the, see if I can change the color on that. There we go. Let's go with purple. You know how I like purple. Okay, so we have a point here. So that point is roughly here and here. So we can say that this point is at 550. Okay, so that's 20, 40, 50. This point here is roughly at 17, 170. All right, so now let's go take those points down on the board. So I'm going to write 550 and 17, 170. Okay, so we have to remember what we're doing when we do statistics. We need to really look at what is our domain. So our domain is chapters. So this one is going to, so the X values are chapters. And the Y value here is pages. So we should remember that when we're finding the line of best fit, because we need to know, does this make sense, the line of best fit? All right, so let's go ahead and find the slope. So when we have slope, we have m equals y2 minus y1 over x2 minus x1. So if this is y x2 and this one's y2, I'll put it right there. This one's going to be x y1. Let's just put x2 up there so it's all the same. All right, so we're going to put that in. So y2 is 170 minus y1, which is 50, over x2 is 17 minus x1 is 5. So that gives us 120 over 12, which is just 10. Because there's 1 and 10. Okay, so we have a slope of 10. Now we can use the point slope formula. So the point slope formula is y minus y1 equals m x minus x1. So we have y minus y1 was 50 equals the 10 times x minus x1, which is 5. All right, so we're going to distribute, and we're also going to add 50 to both sides. So we'll do two things at once. So we get y equals 10x minus 50, because 10 times negative 5 is minus 50, and 10 times x is 10x. And then we have plus 50. Well, that just equals 10x. So that means we have an equation y equals 10x as our line of best fit. So let's go back to the graph and see if that makes sense. All right, so we have this graph here, and we see, well, we have a line of y equals 10x. So that means that my y-intercept is 0. And it sure does go through 0. Okay, it also means I'm going to rise. If I rise 20, I move over 2. Well, 20 divided by 2 equals 10. So that is the slope. Okay, so let's think about, does this make sense? So if I read 0 chapters, I've read 0 pages. Does that make sense? It does. So we're good to go. That's a great line of best fit. And we would just write it as y equals 10x. Like that. Okay? So that would be our line of best fit. All right, let's look at an example. Okay, so we have the length and wingspan of hawks. And they give us the two, they give us the two, let me move that over there, the two lines right here. We have this one, we have 1430 and we have 1939. Okay, so let's go ahead and process that one. We'll write that down. 1430 is one of the points on the line. And we have 1939. Okay, we look again to see, well, what is this length? The domain is length right here. So we're going to note that this is length in inches, and we're talking about the length and wingspan of hawks. So our range is the wingspan. So this is the length of the wing, and this is the wingspan. Of hawks. Okay, so we have to realize, we have to make sure that our line of best fit makes sense. Okay, so we're going to go from there. And if you didn't see these actual points, so if we go to 14, that's right there at about 30. And if we go to 19, which is right about here, go right here, and that goes right here to about 39. So that's where they got the 2 points. So that's the 2 points that are right on the line. We don't want to take these points because these points are not on the line when we're trying to find the line of best fit. So the line of best fit, again, is the average of the data. Okay, so let's go and see if this makes sense. All right, so first we're going to get the slope. And again, we're going to do the x1, y1, x2, y2. So we have 39 minus 30 over 19 minus 14, which gives us 9 over 5. So that's our slope. So then we put it into point slope, y minus y1, which is 30, equals 9/5 times x minus x1, which is 14. We're going to distribute again, and we're going to add 30 to move it over here. So we have y equals 9/5 x, and that's going to be 9 times 14, so that's going to be minus, and we have 36, so 126 over 5. Let's go ahead and multiply this by 5 over 5 since we have a denominator there. So that's plus 150 over 5. So then our line of best fit becomes y equals 9/5 y. And that's going to be, if we add 4 to that, that gets us to 30, so 24. So we have plus 24 this is our y-intercept. Okay, so let's take a look at what does 24/5 mean. So 24/5 ends up 4 and 4/5. And this is a y-intercept. So that means when our length span is 0, so when the length of the wing of the hawk is 0, the wingspan is 4 4/5. Does that make sense? No, it doesn't. So we have to look at the extremities of our line of best fits, because it fits when the line is in the middle of the data, but it doesn't fit sometimes on the extremities of the data, on the ends of the data. So with this case, it doesn't work for the line, for the y-intercept, because if you don't have a wingspan, you don't have a hawk. I mean, if you don't have a length of a wing, you don't have a hawk to have a wingspan. So in this case, it just doesn't work. Okay, so in statistics, we always have to think about what does it really mean, and does it make sense? All right, that's it for today. You have a wonderful day. Bye-bye.